Let's have a look at the next type of graph, the square root function. So it's the graph of y equals the square root of x, or y equals x to the half. Okay, what does it look like? It looks something like this. Got the point here 1, 1. That's because if y equals the square root of x, square root of x, and x equals 1, y will equal 1 because the square root of 1 is 1. Another point here, we've got 4, 2. If y equals the square root of x, and x is 4, y equals 2. Hence the point 4, 2, and so on. We've got square root of 9 is 3, square root of 16 is 4. So there's our general shape of the graph of y equals square root of x, or f of x equals the square root of x here. This is a pretty crucial point, 0, 0, and we call that the end point. Okay, that's the end point of the square root function. There. Notice how it doesn't dip down into or doesn't go into the negatives there, because you can't get the square root of a negative number. Well, it's not a real answer anyway. There's a whole series of maths about the square root of negative 1, complex numbers, but for our intents and purposes it's not defined for any value of x less than 0. So therefore, if we look at the domain of this function, okay, it's from 0 to infinity. Look at the range of this function, okay, it is the same. It goes from 0 up to infinity. So no negative values for x or y, so it's just in that sort of positive quadrant, like so. Once again, we've got dilations, and the red graph here, notice how all my x values here have been doubled, up to there, up to there, up to there, so on. So the red graph here is y equals 2 square root of x. That's been dilated by a factor of 2 from the x-axis, and you can see how it's moved further away from the x-axis by a factor of 2. The distance the points are away from the axis is doubled. The green graph here is y equals a half square root of x, or square root of x on 2. It's being dilated by a factor of a half from the x-axis, which in fact brings it closer to the x-axis like that. So 4, 2 becomes 4, 1, 9, 3 becomes 9, 3 on 2, and the point 16, 4 becomes 16, 2. So there's our dilations. And the greater the higher the coefficient of the square root of x there, so higher that number there, the bigger the dilation away from the x-axis. Reflections. Okay, the bottom graph here would be y equals negative the square root of x. Okay, so all our values of x, all our values here, sorry, are reflected in the x-axis. So from there down to there, so on. So the graph goes underneath. Because, for example, if x is 4, let's take that graph. If x is 4, we get y equals negative of the square root of 4 equals negative 2. Okay, so if x equals 4, y equals negative 2. There would that point be there. So a reflection in the x-axis. Right, here we've got a reflection in the y-axis. So this one here would be y equals negative, sorry, this graph here, I should say, the red graph, negative square root of x. Sorry, go back a step. No, it's not. It's the square root of negative x. So when the negative is contained within the square root sign, we get a reflection in the y-axis. Why do we get that? Well, if y equals the square root of negative x, and say x is negative 1, we get y equals the square root of negative 1, y equals the square root of 1, y equals 1. So hence when x is negative 1, y equals 1. There's that point there, negative 1, 1. Okay, we've got our horizontal translations. Our black graph, of course, is y equals the square root of x. Now we've got an endpoint there of 0, 0. Here we've got an endpoint of 2, 0. The graph has been shifted 2 places to the right, and that's going to be the square root, y equals the square root of x minus 2. So once again, same pattern, a negative 2 there shifts the graph 2 places to the right. So no prize for guessing over here what this graph would be. Okay, it's got an endpoint of negative 3, 0. That's its endpoint. So it's y equals the square root of x plus 3. It's been translated 3 units to the left. Vertical translations, up and down. So our black graph here is y equals square root of x. This one is, the blue one has been translated 2 units up, so it's y equals the square root of x and plus 2, and notice how the plus 2 is well separate from the square root sign, as opposed to, it's completely different to this, where the plus 2 is in the square root sign. It's square root of x plus 2, which is separate. Alright, the bottom graph here in the red, it's been shifted 3 places down, so it's y equals the square root of x minus 3. Taken 3 units down. Alright, this is an interesting situation. So, we've got 3 types of graphs here. And if you look at this one, actually we'll come back to that. I want to show you this first. We've got y equals a square root x minus b plus c. Okay, that's the combination of transformations. So the endpoint there would be the amount the graph has shifted to in a horizontal direction and the amount it's shifted up. So that's the general form for the square root function. The square root function can take 4 basic shapes. And we've got here a point in the middle of the graph that we've defined as b, c. Okay. The black graph here would be y equals a square root of x minus b plus c. Okay, so in other words, a graph that's been, it can be shifted left or right or up or down. Okay, but it's the original shape. Okay, curving up that way. Alright, we've also got, so in that case there, a would be greater than 0, that is, a is a positive number. If we're looking at the red graph, okay, this is a situation, same general graph, but this time a is less than 0, so it's reflected in the x-axis. Okay, so the black graph is our orthodox graph, where a is a positive number. The red graph is our orthodox graph, where a is a negative number. Now on the other side, these 2 graphs going the other way, these are reflections in the y-axis. So here's our general shape here. Let's make that a bit smaller. In fact, I'll just have that out for a moment. This is a situation where we've got a square root of b minus x, so a negative x inside the square root sign, plus c. So notice how it's curving the opposite way. It's a reflection in the y-axis. And the green graph here, in top right, that would be if a was greater than 0 for that one. Okay. The blue graph here would be this scenario here, but we've got a is less than 0. So to summarise, you've got the x minus b graphs, or a square root x minus b plus c graphs, where a is positive and a is negative, and you've got the reflection in the y-axis graphs, a square root b minus x plus c, where a is positive and a is negative. So you've got 4 different scenarios there. Let's look at our transformations then to take us from y equals the square root of x to y equals negative 3, square root of x plus 5 plus 3. So what are our transformations that are going to take us from one to the other? Alright, so we look at dilations first, as usual. Okay, so we've got a 3 there. So it's dilated by a factor of 3 from the x-axis. So that deals with the 3. We've got a negative 3, so that means it's reflected in the x-axis. We've got positive 5, so that means that it's translated 5 units to the left, and we've got a plus 3 translated 3 units up. Incidentally, because of the last two, 5 units left and 3 units up, its end point would be negative 5, 3 units to the left, comma, positive 3, 3 units up. What about this one? This time we've got a minus x inside the bracket. Sorry, not the bracket, the square root sign. So the half in front here, underline it there, that means it's dilated by a factor of a half from the x-axis. The negative in front of the half, so that negative there, means that it's reflected in the x-axis. Now we've also got a negative x there, okay? That means it's also reflected in the y-axis. Now, 2 minus x, okay, that means its endpoint will be at 2, okay, so that means it's going to be translated 2 units to the right, and the plus 2/3 out by itself there, translated 2 on 3 units up. Let's look at domain and range, and what we've got to do here is quickly find the endpoint. So I might just draw a line here between these two graphs so we can see them quite clearly. Okay, so let's do a little quick sketch of this first one. Okay, so if we were going to sketch this graph, we've got 3 units to the right and 1 unit up, so it would be like that, with a turning point at 3, 1. Its domain would therefore be from 3, including 3, that's why we've got squarish bracket, up to infinity. And we always have a curved bracket with infinity, so it's 3 zeros the domain, because that's the x values that graph will cover. The y values it will cover going upwards, okay, so the range will be from 1 up to infinity. This next one's a bit tricky. Remember, with the domain and range, what we're really interested in is the shifts horizontally and vertically. The dilations don't really matter. Okay, it's where it's going to be, or where its endpoint is going to be. So we need to find the endpoint of this one. Now, we'll just leave that there. What we need to do is factorise inside this bracket. So what we do is we take 3 outside the bracket, x plus 2/3, like so. Okay, and minus 4 out there. So that gives me the shifts. If I was to do a quick sketch of this graph, okay, for a start, the negative 4 in there, okay, is going to reflect it in the x-axis, and we're going to get a shift. We're going to get a shift 2 on 3 places to the left and minus 4 places down. So if we were to identify that, this is not to scale by any means, it's sort of here somewhere at negative 2/3, comma negative 4. Okay, and because it's been reflected in the x-axis because of the negative 4, it's going to go down like that. So what does that mean for our domain and range? It means our domain, okay, is going to be negative 2/3, comma infinity with a curved bracket. Our range is going to be below negative 4. So that's actually negative infinity. Hopefully you can see the negative there, comma negative 4 with a squarish bracket. What about the domain and range of this one? Okay, so what we've got this time is, because of the negative x, we've got a reflection in the y-axis. So instead of the graph going that way, the graph's going to go that way. Okay, a 4 minus x situation means we've got a translation 4 units to the right, plus 2. Okay, so we're going to get 4, comma 2, and it's going to, as I said, go up that way because it's been reflected in the y-axis. So what's our domain and range this time? Okay, so our domain is everything less than 4. So we can say here that we've got our domain, our domain, everything less than 4 is negative infinity up to 4, square bracket. Our range, okay, the graph will cover all y values greater than 2. So our range is 2, including 2, up to infinity. Let's sketch this one. Y equals negative 2x minus 3 plus 1. Might just identify its general shape. Okay, if we go to this here, it definitely falls into this category here. So it's this orthodox type graph, y equals a square root x minus b plus c, but the a is a negative number, it's less than 0. Okay, so it's going to be that shape there. Alright, what else do we know about it? Well, we know that its endpoint, write that in straight away, its endpoint is going to be 3, comma 1, because it's moved across 3 and up 1. Now what does that mean? Important now to draw a quick sketch. Let's do it over here before we do the actual sketch. I've got my shape, which I identified as that one. I've got endpoint of 3, comma 1. So it's going to be 3, comma 1, and it's going to go that way. Now, why that's important is I know that I have not got a y-intercept. Okay, that graph will never cross the y-intercept at any stage. The y-axis at any stage. So I'm only looking for an x-intercept. That's important because I could waste my time here trying to find a y-intercept when there isn't one. So always draw a quick sketch first. Alright, so let's look for the x-intercept. We make y equals 0. So 0 equals neg 2 square root of x minus 3 plus 1. Good idea here to take all of this over to the other side. So that means, if I do that, positive 2 square root x minus 3 equals 1. Then I can divide through by half. The square root of x, by 2, equals a half. From there I can square both sides. So x minus 3 equals a half squared, which is a quarter. So x will equal a quarter plus 3, which is 3/4. Okay, so let's draw a better copy or a better sketch of this. Okay. So we've got our y-axis and our x-axis, which we should always label. We've got our endpoint here at 3, comma 1. I've identified our x-intercept as 3 1/4. And I know it's going to shape round like that. There's my graph. Okay, so I hope that's given you a bit of an introduction, 20 minutes there, into the square root function. Now, it's worth having a look at exercise 2E. And please try some of the problems out of that. That's all for now.